Hi, thanks for coming this evening. I'm going to introduce myself to save time. So my name is Heather Shorts. I have a PhD in Earth Sciences, and I've been teaching about climate change at John Abbott College for the last 12 years, at least. And oddly enough, this is the only course, or I actually teach two courses about climate change at the CEGEP level, and they're the only two that are specifically about climate science in all of Quebec, in the whole CEGEP system. Hopefully that will change, but we'll see. So I've been thinking about talking about climate science for a really long time, and for many years, I would leave my classroom and my students would be really long-faced and really sad about it, because what I'm going to tell you tonight is actually really frightening. I'm also going to try to follow up the science with the impacts, what's actually going to happen in our lifetimes, and then also what we do now, what that will cause to happen in the future, and then also look at why people aren't doing a whole lot about it. So we'll look at climate psychology, and then I have a whole bunch of solutions for you. So I call this talk the Climate Crisis 101, because I'm going to give you the real basic information behind the science, and then I'll also try to convince you why you should listen to scientists. And I'll start with this fun yet kind of depressing headline, which was July was the hottest recorded month in human history, in all of human history. So it's quite serious. I wanted to just start with a little bit of an explanation about the difference between the climate crisis and ecological crisis, because there is a difference. And yeah, we should be paying attention to both of these things. And when I show this to my students, a lot of them are really worried about plastic straws, because on Instagram they've seen little animals with straws in them somehow. So yes, you should worry about plastic straws if you don't want to harm animals directly. However, this is really, really small in comparison to the larger ecological crisis and the climate crisis. I wanted to show you this headline about a review paper that came out over the summer months, and it was a scientific paper that looked at a whole bunch of other scientific studies across the globe that basically says we're in the 6th mass extinction right now, and the most scary part of it is that insects are declining at a rate that's 8 times faster than other species. So we're often only concerned or think mostly about cute little mammals that are going extinct because we're mammals ourselves. We don't really have a lot of love for insects, do we? I could live without mosquitoes, but it's quite serious, because the insects are not only pollinators, but they're the bottom of the global food web on land, essentially. So if they go, we basically go. And what scientists have come out to say after that is that the destruction of nature, and it begins really with insects going extinct, is as dangerous as climate change. And I think that's an apt assessment. So why do I bring that up? Just to give you guys something else to worry about. Because the causes of this ecological collapse and the beginning of the 6th mass extinction are the same, and the solutions to them are the same as they are for the climate crisis. So we can solve them all together, which is great. The two main drivers of extinction of insects in particular, and most other species, is habitat loss from human land use, and then also from pesticide use. Right? So just to give you an idea what I mean by human land use, basically humans have turned 72% of the world's land surface into something that works for us. And most of that is through either development that is not in a compact way, or through mechanized agriculture, really large-scale industrial agriculture. And this does two things. One, it disturbs habitat, basically gets rid of habitat for species that are going extinct, even insects, and it also contributes to greenhouse gases. So greenhouse gases are gases like CO2, like methane, that go into the atmosphere that cause global warming. And 25% of all greenhouse gases that are causing global heating right now come from land use change, basically come from getting rid of carbon sinks, intact ecosystems that do photosynthesis that take CO2 out of the atmosphere. So this is an extreme example of that. fires that are going on right now in the Amazon, and this is not helping in the fact that it's actually putting CO2 in the atmosphere very quickly, but it's also getting rid of trees and an intact forest ecosystem that takes CO2 out of the atmosphere. Right. So that's the difference between ecological destruction and the climate crisis. So what's about the climate crisis? Why do we always talk about CO2? CO2 is important to think about when we're looking at global heating and the climate emergency, because it's the single most powerful control on Earth's climate, the amount of CO2 in the atmosphere. And it has been throughout geologic history, so throughout the last 4.5 billion years of Earth's history. So that's a control on climate, and everything depends on a stable climate. Everything that we do, everything that we care about, everything that we get up out of bed in the morning to do depends on this. So you can also think about this in terms of our home. The stable climate that humans have evolved within for the last million years or so is our home. And once we've got that, we can put things in it that we like electricity and running water and heat, and cute little animals and plants, and people. If you like people, you can put them in your little home with you. But all of that depends on having a stable climate. You can even look at money as depending on being in a stable climate. You have to have a home first. It doesn't matter if you earn tons of money if you don't have a place to live, right? So if we get rid of that, then we basically undermine everything that we care about. So that's why we talk about CO2. It's a greenhouse gas, and it's the one that humans have been putting into the atmosphere since the beginning of the Industrial Revolution. So how do we know that CO2 that's been going in the atmosphere that causes this extra global heating comes from human activity? Well, it's because of two reasons. The first reason is that CO2 that has been accumulating in the atmosphere since the Industrial Revolution has what we call a human fingerprint to it. There's two different kinds of carbon that make CO2 commonly in the atmosphere, and the carbon that comes from photosynthetic organisms like swamps and like phytoplankton in the world's oceans here, they prefer to, when they're doing photosynthesis, take CO2 out of the atmosphere that's made with a lighter carbon isotope. So they prefer to use C12 as part of that CO2 rather than C13, because it's just a little bit lighter, so it's just a little bit easier to incorporate into their tissues. Right. Fossil fuels, as I have represented here by these big black blobs, are made out of the remains of ancient photosynthetic organisms. So they have this signature of carbon that is more of the lighter type carbon than the heavier type carbon. And that is a signature of photosynthesis. So since the Industrial Revolution, we've seen an increase in the atmosphere of the proportion between this lighter carbon isotope that makes up CO2 and this heavier carbon isotope that makes up CO2. So you can think of it in simpler terms. You can say the lighter one's the red carbon and the heavier one's the blue carbon, so that the red carbon is the fingerprint of fossil fuels, and we've seen more of it proportionally in the atmosphere since humans began burning fossil fuels. So there's no other place that the CO2 that we've recorded in the atmosphere from the Industrial Revolution could have come from. Then the second line of evidence that we know is coming from human beings is climate modeling. So climate scientists use climate models to try to predict the future. And one of the ways that they test them and make sure that they're actually behaving, this computer model, the way our very complicated climate system behaves, is by testing the model against past climate records. So what you can see in this graph is, since the Industrial Revolution, in the black line, actual recorded surface air temperature. Notice, for one, that it's really squiggly, right? That tells you that the climate system is really complicated. It's not simple. It's not a simple response of you put more CO2 in the atmosphere and then it just goes up directly. So what you can notice here is that in the blue line, like so, and there's error margins on either side of the blue field, if we take our climate model that's a computer simulation that's built to operate like our present climate, and we put into that model only the amount of CO2 that could have come from natural sources like respiration and volcanoes, then we can't replicate the temperatures that we've experienced over the last 50 years or so. It cannot account for that temperature change. But if we add into that human factors, anthropogenic means human, basically burning of fossil fuels, so the amount of CO2 from industrialization, it absolutely matches the temperature record that we can see in the last 50 years. It didn't come from outer space, it didn't come from aliens. This is the only place that we could have enough CO2 put into the atmosphere that would replicate the temperatures that we've already experienced. So these are really the two main lines of evidence that demonstrate that the increase in CO2 in the atmosphere is coming from humans. There's no other place it could come from, right? So then the second question I often get when people find out that I teach about climate science is, well, why should I trust scientists? Aren't they all just in it for the money? Aren't they just want to be famous? Well, not really. Not really. I'd be really happy if what I was telling you tonight is not true, but the science says it is. So why should you trust climate scientists? Well, for one, anything that a climate scientist says in a research paper goes through a rigorous process called peer review. So a scientist can't just go on Twitter or go on Instagram and say, like, wow, the sky is falling, because they have no evidence to suggest that. So every research paper that's published has to go through a pretty rigorous system of organized scrutiny. You can't just write what you want to write. Every research that you do is reviewed by at least 3 other people who are also experts in the field. You quite often have to rewrite it after you get the comments back, and then eventually you get to publish it. So it takes a long time. It's one of the drawbacks of peer review, but in that way, it's a system of built-in checks and balances. Finally, after, or sort of in the mid part, after a lot of research papers are published that come to the same conclusion, and in this case I'm talking about climate change is happening now and it's caused by human activity, we then can say that we've reached a scientific consensus. A scientific consensus is kind of like a topic passing a jury of geeks. These are a bunch of people with PhDs in specializations of climate science. So this jury of geeks re-reviews basically all of these papers, or at least a lot of these papers, and we're like, yeah, the evidence stacks up and suggests that climate change is happening now and it's caused by human activity. So just a couple of weeks ago, another paper was published about this consensus on this topic, and now 99 out of 100 climate experts think that the evidence shows that humans are changing the climate. That one little red person there in the crowd is actually probably a statistical anomaly. So really, at this point, all climate experts believe that the climate's changing and that it's caused by human activity. So we've definitely reached a scientific consensus, and that's as close as we can get to scientific fact. Right, and then thirdly, in climate science, we have the Intergovernmental Panel on Climate Change. And this is an organization that is international. Its members are not paid to re-review this science. However, they do it because it's important, and they want to make sure that the recommendations that they give to governments are spot on, are supported by the evidence. So it consists of thousands of scientists from almost 200 countries, lots of different cultural backgrounds, different socioeconomic backgrounds, and they set standards and review these evidence for human-caused climate change, and then make recommendations for policymakers. Now, imagine being in a room of 200 scientists and then also some social scientists, political scientists, and economists, and having to agree on a statement that you're going to give to all of the governments of the world to form policy about. It's not easy to do, coming to an agreement on a statement. So, by the very nature of this organization, everything they say is conservative. Every statement that they issue is very, very reticent in its final form. So when the IPCC says something like, we need to keep warming from pre-industrial levels to 1.5 degrees Celsius, they really mean it. They really, really mean it. They're not exaggerating, they're not alarmists. This is even a conservative estimate, and I'll explain to you why. So last October, the IPCC, who usually meets only, well, they meet every year, but then usually only issue a report every 4 years, had a special meeting, issued a special report because they said, this is even more serious than we've ever imagined. So they came out with a new report that says that we need to really keep global warming to this amount above pre-industrial levels. And what this means is that we need to reduce CO2 emissions, not the total amount in the atmosphere, just emissions, so that's the easy one, by 45% within 11 years, and that's a minimum. Where we're headed right now, business as usual. If we keep living our lives the way we do, if we keep driving our cars to the mall and buying lots of stuff from far away and having it shipped to us and consuming lots of goods and driving big gas-guzzling cars and flying on holidays all over the place, we're going to see 1.5 or 4.5 to 4 degrees Celsius above pre-industrial levels by the year 2100. And that's business as usual. If we comply to what we promised to do at the Paris Climate Accord in 2015, we would still see heating by 3.5 degrees above pre-industrial levels in that same time period, which is not okay, really, for life on this planet. So this statement by the IPCC is still conservative, and all of their estimates include beginning to reduce emissions by the end of 2020. So all of the scenarios that they put forth in their policy guidelines mean we have to start reducing CO2 emissions by the end of next year. That's in about 16 months. So no time to lose. So remember that I said that the IPCC, every statement that they make is very conservative. And it's conservative because it's a bunch of people having to make the same kinds of compromises to issue something that governments all over the world will try to live by. It's a minimum estimate because in their estimate they don't include something called positive or possible warming feedback. So these positive warming feedbacks that would already have us above that threshold by the year 2100, probably even sooner. So to walk you through what a positive feedback is, let's say we put extra CO2 in the atmosphere, which we've done. That causes the surface air temperature to rise, right? So everyone understands that relationship. That then can cause something called permafrost to melt. Permafrost is permanently frozen ground. A lot of it's in Canada, a lot of it's in northern Russia. And permafrost contains methane gas in it. Methane gas is a very powerful greenhouse gas. It's much more powerful than carbon dioxide. So once you melt that permafrost, methane is released, that goes into the atmosphere, and that causes surface air temperature to rise even more. Whether or not we take away this, that started the feedback. So positive warming feedback is a self-perpetuating mechanism of change in a response to that change. This means that the predicted warming by the IPCC is not linear. This could accelerate very, very quickly. And we know that this has happened in Earth's past. This is why it's quite serious. Does everybody sort of follow that? Yes, great. So, what can we learn from geologic history? I'm trained as a geologist, so I like to look at the past. It's the best predictor of future behavior. So normally, if we look at the climate past, it changes very, very slowly over millions of years, and it changes very slowly over millions of years by the amount of CO2 that's in the atmosphere. Normally the processes that take CO2 out of the atmosphere are very, very slow. Taking things out of the atmosphere using plants is fine, but then those plants die and the CO2 goes back in the atmosphere. We're talking about putting it into rocks and then keeping rocks as solid rocks for millions of years. But sometimes it can change very quickly, and we know this by studying ancient rocks, but also by studying isotopes and ice cores from ice sheets. So let's look at a couple of those examples of the climate changing really quickly. And notice it's thousands of years when we're talking geologic history. Right. So we'll go to the big bad one first. The end Permian mass extinction was about 250 million years ago. And this was a time when a lot of extra CO2 was put into the atmosphere very, very quickly, geologically speaking. So this happened from huge volcanic eruptions in the area of central Russia that put CO2 in the atmosphere slower than what we're presently doing. So we're presently adding greenhouse gases to the atmosphere faster than during the eruptions that caused this end Permian mass extinction, and our rate of emissions are accelerating. They're not declining. 97% of all life on the planet went extinct within about 100,000 years. That was really fast, geologically speaking. So let's look at another example. If we look at the Paleocene Eocene thermal maximum, don't worry, there's not going to be tests on this afterwards, but this is the PETM for short. And what this was an abrupt change in surface air temperatures. Temperatures rose between 5 and 6 degrees Celsius over, again, a very short time period, geologically speaking, over about 10 to 30,000 years. And this was also associated with mass extinctions, not quite as much because it wasn't a global event. It was isolated mostly in the North Atlantic. And it lasted for about 100,000 years, and it resulted in about 30% of organisms on the planet going extinct. So not that bad, but still a pretty decent mass extinction if you're looking at that. We are presently adding CO2 to the atmosphere faster than what happened to cause this event, right? So if we compare those two events, we can, because it's fairly recent, so it's only about 55 million years ago, we have sea sediments that record this event, and this blue line shows the rate at which CO2 was going into the atmosphere to cause this event that then caused 30% of all life to go extinct. And the red line is what we're doing right now. So the rate at which we're putting methane from essentially melting permafrost into the atmosphere is much faster than the rate at which it happened naturally in geologic history. So one more example of a rapid climate change that we can learn from is 35 million years ago, Antarctica looked like this. Antarctica was ice-free and sea level was much higher. Sea level was probably about 60 to 70 meters higher than it is today. And that's what happens when you have no water traps in glacial ice on the planet, and that's what the world was like. So to give you a bit of a background to this, the world was cooling off after a fairly long period of warmth. So the dinosaurs had a great time, they went extinct, lots of other warm organisms evolved and went extinct, and then things were cooling down, and they were cooling down slowly because of the slow drawdown of carbon dioxide from the atmosphere, putting it into rocks and then keeping that CO2 in the rocks for millions of years. So at this point in time, what happened was a positive feedback started to kick in. Surface air temperature lowered enough so that snow and ice started to stay year-round on Antarctica. That snow and ice is very reflective. It has something that we call a high albedo. You know this from going outside in the winter. You have to put your sunglasses on if it's a sunny day. So that reflects more solar energy back out into space more quickly. That causes surface air temperature to cool, which then causes more snow and ice to accumulate, and eventually you start to form an ice cap. And that then causes the local climate to cool even more, and eventually, if it's as big as Antarctica, the global climate to cool. So scientists did, even 10 years ago now, a study that estimated how much carbon dioxide was in the atmosphere at the point where this positive cooling feedback kicked in to go from this kind of a world to the kind of a world that we live in today. And they were able to determine that it was about 450 parts per million of CO2 plus or minus 100. This is where we are today. We're at 414.7 parts per million CO2 in the atmosphere. Does anyone know how quickly it's increasing? I guess we're good. It used to be linear, so it used to be 2 parts per million every year, but now it's actually accelerated, so it's an exponential increase. If we just stick to the linear 2 parts per million per year, we're going to reach 450 by the year 2030. By the year 2030. So the choices that we make right now in the next 10 years are going to determine whether or not this positive feedback gets started, but in the opposite way, to cause warming that will end up melting Antarctica and causing sea level to rise by 60 to 70 meters. That won't happen in our lifetimes, I'm telling you that right now, but it's possible that it could happen in the next generation's lifetimes. It's possible that it could happen in the lifetime of your grandchildren. So, what does this all mean? That's the science. And a prominent climate scientist has stated that a rise of 4 degrees Celsius by the end of the century is incompatible with an organized global community. And there aren't too many people who disagree with that. So if we continue business as usual, living our lives the way we do, and we do nothing about it, then we will see a rise of at least 4 degrees Celsius. Again, that's a minimum estimate. It does not include positive warming feedbacks that could kick in and cause this to happen much sooner and cause it to happen even more severely. So keep in mind that within this scenario, even with the very conservative scenario, an 8 degrees Celsius warming is possible within that same time frame. And that's also, again, not including positive feedbacks that could accelerate it. So let's think about that for a second. It's good to reflect on things. The new IPCC report advises that we stick to below 1.5 degrees Celsius warming from pre-industrial levels. We've actually already warmed 1 degree Celsius on average globally. Canada has warmed at twice that rate. So Canada has warmed by 2 degrees Celsius from pre-industrial levels. Business as usual is going to result in at least a rise of 4 degrees Celsius. And that estimate does not include the onset of these positive warming feedbacks that we know are not only possible, but probable, because they've happened over and over again in Earth's past. So, what does that mean for our future? It means a lot of things, and pretty much none of them are good. So, we're going to see a food crisis. It's going to cost a lot more. It's going to be hard to get food. There's going to be shortages of certain types of food. I often tell my students at this point that beer will be really expensive. That makes them pay attention. We're going to see a health crisis, so tropical diseases are going to spread. We'll have hotter summers. We're going to have more heat-related illnesses, increase in crime. My favorite is reduction in cognitive ability. So by 2100, the amount of CO2 in the atmosphere outside will be high enough to induce a 21% reduction in human cognitive ability, which is my favorite. There'll be political crises, more than we have right now. So the UN, again, which is a conservative estimate, estimates 1 billion climate refugees by the year 2050. And then, of course, the climate changes themselves. So we'll have longer hot spells, longer cold snaps, longer dry spells, and flooding, of course. Sea level rise is always difficult to estimate, but again, a really conservative estimate is a 4-foot global average rise by 2100, and that's average. Places that have warmer water will see a higher rise, places with cooler water will see a lower rise, but it's still a major problem for most cities around the planet. So to elaborate on that a little bit, some new studies have come out that link directly the amount of violence with amount of degrees Celsius warming. So for every half degree warming, we're going to see about a 10 to 20% increase in the likelihood of armed conflict. But it's not just armed conflict that we'll see an increase in. We'll also see an increase in municipal crime rates, in domestic violence, as well as violence associated with natural disasters, which we'll see more of as well. There we go. So municipal crime rates and even self-violence increases with higher temperatures. We'll also have economic problems, and this is the part where most people sort of sit up and pay attention, because oftentimes, and actually I just had a student last week raise his hand and say to me, but isn't it really a question of either capitalism or the climate crisis? And no, that's totally not what you should be comparing these two, because the climate emergency is really the largest existential threat to our global economy, pretty much ever. So if we look at the degree Celsius warming, it costs an average about 1.2% of GDP, which is based on the US. The median projection is for a 23% loss in global GDP by the end of the century, resulting from changes in agriculture, labor, health, crime, storms, mortality, all of that. But that's not all, because you could potentially have global GDP reduced by more than 50% in the models. Economics, by the way, uses systems modeling just as much as climate science does. So if you don't believe climate models, you might as well not believe economic models. So there's a 12% chance that we could reduce our global economic output by 50%, and then there's a 50% chance that it's going to be lowered by 20% or more. That doesn't mean a lot to me. I'm a climate educator and earth scientist, so I looked it up, and the Great Recession in 2008, which everyone flipped out over, reduced global GDP by about 6% in a one-time shock. people were afraid that the whole global economy was going to implode, and it would have if we hadn't used our taxpayer dollars, not in Canada so much, but to bail out the big banks that were too big to fail. Imagine what climate change is going to do. So, imagine what the world would look like today with an economy half as big, which would produce only half as much value, generating only half as much to offer the workers of the world, or even just 20%. Even if just 20% of the students of the graduating class at John Abbott next year couldn't get jobs, ever. That would be absolutely devastating to the economy. So what the IPCC recommends is that we limit warming to 1.5 degrees Celsius, and that this is going to require transformative systemic change. They're not talking about little incremental changes. They're not talking about, buying metal straws instead of plastic straws. This is transformative systemic change. This is from an organization whose statements are always conservative. They're always reticent, and they're always based on the available scientific evidence. This is a massive statement for them to say. So, why aren't we treating this like the emergency that this is? I often use the analogy of the Titanic. We're on the Titanic. We know exactly where the iceberg is. We know the size of it, we know the shape of it, we know when we're going to hit it. What we need to do now is I'll grab the wheel and steer away from this. So, in an effort to try to understand why people weren't responding the way I thought they should when I told them all of the science and the facts, I thought people would be jumping out of their chairs and like, okay, let's go do something. It doesn't happen most of the time. So I started looking into climate psychology and trying to understand why people behave the way they do when they heard about the climate emergency. And I came across this book, and this fella is a PhD in economics as well as in psychology. And he was wondering the same thing, and he discovered that the more information that we have about human-caused climate change, the less we actually do about it. And this is especially true in wealthy, English-speaking countries. So what he concluded was that it has to have something to do with the way we're communicating about the climate emergency. And he explained this by looking at our psychology, how our brains have evolved as human beings over the last 500,000 years, a million years, to cope with or deal with disturbing information. So if we look at just basic climate psychology or human psychology, denial is a very human emotion. Denial is something that humans need and use in order to be innocent about a really troubling recognition, and sometimes it's really self-preservation. So human brains are hardwired to ignore threats like global warming and climate change because we're more interested in self-interest, status, social imitation, short-termism, and we have a pretty wonky risk vividness, which I'll talk about next. The good news is that these tendencies influence our behavior, but they don't control it entirely. Yes, we all have the lizard brain still right in the back of our head, tells us to be afraid of something that's much more exciting than climate change, but they don't control it entirely. So risk vividness is akin to evolutionary risk perception, and you can imagine that if we were still living on the savannah in Africa, it's really important to be worried about a potential lion hiding behind a bush that could kill you instantly than worrying about when the rains are going to come. So it's totally normal for the human brain, when confronted with a kind of a risk, to be really, really concerned about sensational, outrageous, not very likely to happen risks, because we had to be for a long portion of human history. So if we look at this piece of artwork, actually, it's based on statistics from the United States, but humans are way more worried about being in a terrorist attack, or gun crime, or bird flu, or stock portfolio crash, than they are about things that are actually a danger to them, like extra heat or credit card fraud. And I added in here climate change, because it's something that we are not programmed to worry about. CO2, which is causing global warming, is invisible, it's tasteless, it doesn't smell, you can't touch it, you can't see it. The only reason that you know that this climate is in a state of emergency is because you listen to people like me. So this is really pretty far out of the reach of our lizard brains, our basic psychology as human beings. So it's really, really normal for humans, when faced with troubling information, to not do anything about it because of this thing, cognitive dissonance. So in a room of 100 people, 74 of those people are not really going to leave and change their lives or their behaviors or do anything about it. And that tells us that attitudes are not changed by information alone. So for most of you, you're going to leave tonight, hopefully not, feeling this icky feeling in the back of your head, and that's cognitive dissonance. I often use the analogy of smoking. Everybody knows that smoking's bad for you, it's going to shorten your life, but people still do it because they're addicted to the nicotine. And what do you tell yourself when you're out there having a cigarette that you know you probably shouldn't have? You tell yourself, like, well, you know, I'm healthy otherwise, it probably won't be that bad. Or my grandma lived to be 90 and she smoked 3 packs a day, so I'm going to be fine. So instead of changing your behavior, you change what you think or what you know about the topic. And that's exactly what happens with climate change. So it's way easier to change the thinking than to change what we do. You get rid of that cognitive dissonance and we feel better, yay. So, cognitive dissonance about troubling facts like the climate emergency results in people using these 5 different coping mechanisms or barriers to taking action on the climate crisis. And we all have them. I mean, I have them too as well. So the climate message, talking about climate change as, oh, we're doomed, we're screwed, there's no way out of this, it's hopeless, makes people feel really bad, and then therefore they'll come up with excuses like, well, you know, it's not happening right now, I'll probably be okay, or it's happening someplace else, it's happening in the Bahamas, or it's happening in South Asia, so we'll probably be fine here in Canada, and I even hear my own colleagues say that stuff. Doom is another excuse for not doing anything about the climate emergency, and that's just feeling overwhelmed. You feel hopeless. What can one person do? I'm not sure what I can do, and if I did anything, it wouldn't make a difference anyway. That's very, very common. Dissonance is one that I see a lot of as well, and that's the idea that this system of growth capitalism has worked really well for me, it's worked really well for my generation, why isn't this going to work for the future generation? That's just ridiculous scientists trying to make lots of money and be famous somehow, I don't know. And it's also often people saying like, well, I've worked hard for my life and I deserve to drive a Hummer if I want to. You know, I deserve this. So it's not wanting to realize that the present situation is not working, and that means that you have to actually give up something in order to, well, for future generations to even live. Denial and identity go together quite often, but there's 2 different forms of denial. There's active denial and passive denial. Passive denial is that troubling recognition that you just can't deal with it. So a lot of people, perhaps people who have to take care of a sick family member, or people who have lots of kids and you just like can't deal with it, you don't think about it, you're sort of passive in denial because you can't spare the energy to deal with it. But active denial goes with identity because it's when people are actively counteracting scientific arguments in ways that actually don't make any sense, but they're actively going out and trying to say, no, this isn't happening, climate change isn't real, it's a hoax, etc., etc. And that's usually because the idea of it threatens their own personal identity. So it's very commonly associated with conservative political beliefs, in which the story goes that environmentalists or the green left, I've heard that one recently, want to take away your freedom, and they want to take away your, boat and cars and nice house. And that, therefore, acknowledging that climate change is happening means that they have to actually look at their lifestyles and realize that they're part of the problem, and that's very, very difficult for people to do. It's very difficult. So we can actually flip over these barriers and get around them and get people to take action on climate change by pointing out the fact that every little thing helps. So every little action helps to change social norms. We can also frame climate in terms of a supportive, perhaps happy ending, where we all work together to build a community that can weather the coming climate crisis. Simple actions, again, everything counts because it helps to change social norms, and we need to start telling stories to work towards rather than having something just to run away from. But I'm not saying that we shouldn't tell people the honest truth, because I think more people are unaware of the truth than they are aware of it and then scared enough to take action. So what do we do about it? We either take the brave, bold steps necessary to fundamentally change the way we live on this planet as soon as possible, or we don't. And if we don't, we're not just going to keep going on business as usual forever. Things will change whether we're ready for it or not. So, transformative systemic change in all aspects of society. We need to envision a new way of existing on this planet that is balanced, that is equitable and fair to all living things. We need to change social norms. We need to participate in collective CO2 reducing activities. Individual actions help, but they don't help quantitatively taking CO2 out of the atmosphere. It's not enough. We absolutely need to do these things together. And then we need to pressure governments to make the bold decisions needed to make use of our approximate 10-year window of opportunity to reduce CO2 emissions by 45% by 2030, probably a lot more, probably a lot sooner, right? So one of the ways we can do this is just talking to people about climate change. We need to talk to people about it. This is not something that you're going to go to a dinner party and be like, hey, let's talk about the climate emergency, because you won't be invited back, right? It's not something that's fun to talk about, but it's absolutely necessary to talk about. And we have to do it in a compassionate, non-argumentative way. We're all humans. We all have grown up in and benefited from basically the system that provides us with our livelihoods right now. But we have to recognize that that system's not working for everyone anymore. It's certainly not going to work for the people of the next generation. And we need to be responsible about our lives and our luxuries and our conveniences. So, no blame and no guilt. Let's be honest about it, and then let's work together to start to get CO2 to decline by December 2020. This is our chance to create a fairer, more equitable world, and a world that doesn't involve humans being responsible for the extinction of millions of species and basically wrecking the place for human generations. Because humans don't get me wrong, humans could actually go extinct from this, just not in your lifetimes. But it will happen if we continue to live the way that we do. So by talking to people about the climate crisis, we can start, instead of a climate positive feedback, a societal positive feedback of change before those climate feedbacks kick in. And one of the ways you can go about this is, if in 20 years a person born today asks you, what did you do about the climate crisis when something could have been done about it? Because if we don't do anything about it right now, the next generation won't be able to. It's literally now or never. So here's the top 4 personal actions that you can do to reduce your own CO2 footprint. Have one less child, which most of you probably already made those decisions, so we'll skip that one. Fly only for family. Flying takes a tremendous toll on carbon emissions. It puts a tremendous amount of CO2 in the atmosphere. So to give you an example, one long-haul flight from New York to London is the equivalent amount of CO2 emissions that you would save from being a vegetarian for an entire year. It's massive. So it's not like you can just do one and the other and trade off. No, we have to do all of these as much as possible, as quickly as possible. So follow a plant-based diet and live carb-free. So we'll look at those in more detail in a second. So essentially, one flight from New York to actually Montreal emits as much CO2 as all of these countries in Africa emit. Yeah, one transatlantic flight emits the same amount of CO2 as all of these countries around the world emit.
And how long?
Per person in a year. Yeah. So, if we look at food is really personal, it's a touchy subject. People are really attached to the food that they like. And it's also very cultural. But every study that I've read points out that there's no way that we can meet our global CO2 emission reductions targets by eating conventional meat and dairy products. It's a really inefficient way of getting calories in people in the first place. It uses a lot of land. It also contributes a lot of sort of collateral environmental damage and a lot of methane and CO2 emissions from mechanization and from the cows themselves. So if we're going to try to meet those targets of reducing CO2 emissions by 45% by 2030, probably a lot more, probably a lot sooner, there's no way that we can continue to eat meat that's raised conventionally the way that we do now. So in the big picture, we need to collectively, basically either or both, prioritize immediate emissions reduction and remove CO2 from the atmosphere and keep it out. And there's sort of two categories of doing this. We have to stop putting it up there in the first place, so we have to end fossil fuel-driven vehicles and infrastructure, lower our overall consumption of goods, because everything that we use, everything that we consume is made with energy that is from fossil fuels, essentially. 80% of our economy is run on fossil fuels. And we need to make local renewable energy and local food. So that keeps CO2 from going in the atmosphere in the first place, but to remove it and keep it out, we need to transform the global food system, broken global food system. And then we also need to preserve ecosystems that remain and restore as many more as possible. And those are things that we can work on at the community level. So to give you an idea, Canadians, we often think that we're nice and green people. Canada has the highest per person CO2 output of all of the G20 nations. So of all of the wealthy nations on the planet, Canadians emit more CO2 per person than any of those other people in those wealthy nations. And it's primarily because of fuel consumption and driving big trucks. So if you look at this is from 1999 to 2019, the sales of cars in Canada have gone down since 2009. And around the same time, the sale of big trucks has gone up dramatically. It's massive. So Canadians produce 3 times more greenhouse gas emissions than the G20 average. It's a little bit embarrassing. Yeah, we're supposed to be leaders on this. And most of it comes from places like where we live. So most of it comes from people living in suburban areas. You can see looks like the United States has measles, which is, I think, kind of funny. But the green little dots in the middle of these red circles are the urban centers of cities where people don't drive as much. And instead, the suburbs is where most of the CO2 emissions are made, and that's true in Canada as well. It's just this study was from the United States. So if we look at the eastern seaboard of the United States, you can see all of the suburbs have the highest CO2 emissions. That's a problem, and we're part of that problem. The global food system, we need to eat a plant-based diet. This is an emergency, perhaps sometime in the future when we learn how to raise animals better in a way that takes CO2 out of the atmosphere even, then we can go back to eating more meat. But for now, this is quite serious. Buy food locally wherever possible, organic, because that saves the pesticides, for one thing, and that helps with the ecological crisis and the mass extinction of insects. Know where it comes from, avoid processed foods, because processed foods means more CO2 emissions, basically. What's really, really, really important here, though, is buy what you'll eat and don't waste it. Food waste is, I think, number 3 or number 4 of the most effective ways to reduce CO2 emissions from the start. So we waste a ridiculous amount of food. 25 to 30% of all food grown globally is never even eaten. It just rots. And that makes methane that goes into the atmosphere and causes global warming. Right. So that previous little quote there was by the IPCC basically saying that there's no way that we can meet our CO2 reductions targets if we continue to grow food and meat and dairy the way that we do right now. So one of the solutions is regenerative agriculture, and this is something that the Hudson Food Collective has already been working on. And what this does, what's different about it from conventional agriculture, is that it actually restores the soil carbon content. It replenishes the soil, and then it helps take CO2 out of the atmosphere rather than being a source of CO2 from lots of equipment and machinery, among many, many, many other things. But what I want to focus on is this relatively new idea called natural climate solutions. And it's a no-brainer, basically. So restoring natural ecosystems and then forming ecosystems are probably the most cost-effective way to take CO2 out of the atmosphere. It's been estimated that 1/3 of the greenhouse gas reduction that we need to do between now and 2030 can be provided by these natural carbon solutions. And this doesn't even include marine ecosystems, so if we were able to stop ocean acidification and replenish those marine ecosystems, we could have an even larger impact. So this is from a recent paper just last month. Forest restoration isn't just one of our climate change solutions, it's overwhelmingly the top one. The world's six biggest nations, including Canada, contain half the potential restoration sites. So this paper looked at not even taking over grasslands that are used for growing food and for raising animals, but just where could we plant more trees? Where could we restore forests to be more effective at drawing CO2 out of the atmosphere? So this is really what we should be focusing on. I'm not going to go through all of these quotes, but I'll focus on this last one. Conserving what we have got already is the first thing that we need to do. We shouldn't even be entertaining the idea of cutting down trees or forests or filling in wetlands to build houses. It should not happen. It's really shooting ourselves in the foot. So the real plus is that this is way cheaper in terms of a drawdown for carbon than anything else. CCS is an artificial way of taking carbon out of the atmosphere and then trying to turn it into a solid and storing it underground. It's very expensive, it's not proven, and it's very difficult to do. Whereas preserving forests and wetlands is really simple and it's cheap. So, one thing I want to mention before we go is climate justice, this idea that those of us who have the most responsibility in causing the present climate crisis are the ones that will feel the least repercussions from it in two ways. So one is present day, but countries that are least responsible, so for third world and developing countries, are going to be the ones that are hit the hardest and hit the first by the climate crisis. The other way that we can consider climate justice is intergenerational justice. So the lives of future generations are of no less value than the lives of adults who already exist. And British journalist, I like his quote, "We ate your future to satisfy our greed or luxury and convenience." And it's basically true. And I couldn't not put a photo of Greta Thunberg in this talk. So that's Greta on her school strike for the climate outside of the Swedish parliament last August. And her reasoning was, why bother to learn anything in school if politicians won't pay attention to the facts or to the science that has come out of that very school system that she is avoiding to make a point. So if we look again at this intergenerational climate justice, to limit global warming to 1.5 or even 2 degrees Celsius above pre-industrial levels, children that were born in the 2000s are going to end up having to emit 90% less CO2 than somebody born in 1950. So baby boomers got a lot of CO2 emissions, Gen Xers and millennials less, but if we're going to try to limit CO2 emissions to what will keep us from warming above 1.5 or 2 degrees Celsius, folks born in the 2000s, basically like Greta, are going to have very, very, very different lives. So how do we do this? And how do we do this quickly? We have to do a sort of bottom-up, top-down approach, where you have everyday changes in behaviors. So fly only to visit your family, don't drive your car as much, eat less meat. That will help change social norms, which will make other people who are maybe a little more cautious about this to also change their behaviors. And then that provides sort of breathing space for politicians and other people who have that cognitive dissonance, and then politicians can have the support that they need and want to make these necessary bold decisions. In the meantime, hopefully some of them are going to react and make laws that begin CO2 reductions by 2020 and then decrease by half by 2030, probably a lot more, probably a lot sooner, and then we meet in the middle. So our individual actions help because they change social norms, and that encourages these guys to work from the top down as soon as possible. Sometimes they need a little bit more of a nudge though, and this is where we have groups that are forming around the world participating in direct action. So direct action is a form of nonviolent civil disobedience, just like what was used in the civil rights era in the United States. And the principle is that you have strategic direct actions that create decision dilemmas for authorities, and then you end up forcing some sort of action on the situation. It's nonviolent, and that's really, really important. And it's necessary in the eyes of a lot of folks who have been working on the climate crisis for a long time, because we don't have any time left. We literally have 16 months to start to reduce CO2 emissions. And it has to happen from the top down. It can't just be from the bottom up. So I want to point out that every fraction of a degree matters, because a lot of you are probably thinking, there's no way this is going to happen. I know people, they're not going to change. I really want to emphasize this. Every fraction of a degree matters. Even if we start those positive warming feedbacks, we can limit their severity. If we reduce CO2 emissions drastically, maybe not enough to keep warming to 1.5 to 2 degrees Celsius, it's still going to dictate what our future is like. We choose that. Also, the same strategies for immediate CO2 reduction are needed to help us prepare for a new climate as best we can. So everything that we do to lower CO2 emissions drastically is also going to help us to prepare to live in a very different future, in a very different climate. So we still need to preserve forests and wetlands and habitats. Local food systems need developing. We need to plan for not having cheap fossil fuels at our every wish, basically. So I'll leave you with another quote by the IPCC, which is again a conservative statement. Rapid and far-reaching transitions in all aspects of society are needed pretty much now, pretty much immediately, if we're going to address this. So we have to begin to imagine creating, living, and even thriving in a very different world. And it is going to be very different. So I'll leave you with these 3 take-home points. 1, talk to people. Just talk about it, and talk about it in a way that's not blaming, that's not shaming, that's, hey, we're in this together. We didn't really know until very recently. What matters now is what you do, now you know. Now that you know what's happening, what you do is what matters. We have to be compassionate, we have to be honest and pragmatic, and have courage to work towards these goals together. We can't do it alone. Act collectively, that's my second point, to lower CO2 emissions. So consume less stuff, make it social, and if you feel like it, you can even participate in civil disobedience. Why not? It's fun. But thirdly, build. We need to focus on building a community, building a culture that's focused on consuming less and helping each other more. We need to teach children about climate awareness and stewardship, that we're here as guests on this planet, and we need to take care of the natural world, because otherwise we won't be able to exist either. So, something to work towards, because the world's changing anyway. It's not a question of, well, it's climate or it's capitalism, because that's going to fail as the climate fails. There's really, in my view, no other way to go. So